folks, here we are. We're starting our transformations unit, and we've already talked about reflections. Today we're going to talk about translations. So let's start out with our hopeful understandings by the end of the lesson, and here we go. I can translate a figure from one part of the coordinate plane to another. We're hopefully going to be able to, when given a coordinate plane, and this is a very, very basic example. Let's say we have a triangle over here. We know the coordinates of each point. If we're going to be able to translate it, that means we're going to be able to slide it. Let's say we want to move everything 4 units to the right. And hopefully, of course my drawing's not going to look like it should. Hopefully, we would have the exact same figure here as we would have started with, except for all of our points will have been shifted or translated 4 units to the right. Okay, we also want to be able to say by the end of today, I understand that when a translation takes place on the coordinate plane, that the figure has only been shifted. Okay, it's only been shifted. However, the side lengths should still be exactly the same as the original figure. The angle measures should be exactly the same as in the original figure. Okay, and the shape is exactly the same size. Now let's continue with a few more definitions before we try an example or two here. The pre-image, oh, and I probably should have left that up there, but the pre-image is the original figure on the coordinate plane before it is transformed. So if this is the original figure that I'm starting with, or if I'm just given 3 points, which maybe I would end up graphing anyways, this is considered my pre-image. Okay, if I'm then asked to translate this image 4 units to the right, once again, my figure is not going to be perfect by any means. Let's say that I shifted all 3 of my original points to the right. Okay, this guy right here is considered to be the pre-image, and our new figure is considered to be our image. Okay, so the new figure is considered the image. If the original point, let me see if I can get my pen working here. If the original points were A, B, and C, and remember it can be any letters, it could be X, Y, Z, then our new points are going to be labeled A prime. All it is just a little apostrophe you put there, B prime, and C prime. The primes are only placed there to let us know, it helps us distinguish between our original figure on the left and our new figure, or our image. Okay? So if you ever see this talking about, let me try that again. If you ever see something written A prime, B prime, C prime, it means we're talking about this shape on the right. Or if you see a figure named ABC, it means we're talking about the pre-image, not the image. The primes, the apostrophes, are what tell you which image you're dealing with, the image or the pre-image. Okay, now that we have some of that lingo out of the way, let's look at a couple examples. And actually, number 1 I have here, I'm not asking you to do anything. I'm just showing us a nicer example that's drawn a lot nicer than what I have. So, if you notice, you should probably ask yourself, which one of these figures is my original figure? Which one is the pre-image? If you haven't been able to figure it out, it's going to be the one on the right. How do we know that? Okay, you should know that because my points are labeled A, B, and C, and my points on the image are labeled A prime, B prime, and C prime. So remember, prime means that this guy is the new figure, or the image. Okay, let's try and figure out what happened here. This is a reflection, which we talked about yesterday. And all you see is your new points are placed over here on the left. Okay, so you started here, we reflected over the y-axis, and A prime is placed over here at negative 2, 2. So once again, all we're really worried about is the difference between how you label your figure. So our pre-image is ABC. Our image, our new figure after the transformation took place, after the slide of the figure, which we call a translation, or after the flipping of the figure, which we call a reflection, your new points should be labeled with these apostrophes: A prime, B prime, and C prime. Okay, I'm only showing you this picture so that you have a good visual. Now, we have one example to work through. It says a parallelogram has vertices A, negative 4, 3. Come on, pen, here we go. A, negative 4, 3. I'll put that on there, and that is A. And B is 1, 3. I'll label that guy. That's 1, 3. And C is 0, 1. That's C. And D is negative 5, 1. So everybody knows how to graph, so that part was easy. So this is our pre-image. This is our original figure. And we know that because we're given 4 points, but they don't have a prime. They don't have the apostrophe. So this is just our pre-image. So obviously this is a terrible, my lines are not drawn perfectly straight. But there we go. A, B, C, D. It is a parallelogram. And we have 2 questions below. It says a parallelogram is reflected over the x-axis. Find the coordinates of the vertices of the image. So when we talk about a reflection, if it's reflected over the x-axis, this guy right here, you can do this in one of 2 ways. Let me switch colors here. You can either say, okay, since this is my line of symmetry right here in the middle, we can simply take each of our points and count 1, 2, 3. It took me 3 jumps to get to my line of symmetry. So let me go 3 units in the other direction and plot my new point. Since I was working with A here, my new point is going to be A. That's right, hopefully you guessed it, A prime. Okay? Now you can do the same thing with D. Let's go, oh, it's only 1 spot away from the line of symmetry, so that means you only need to go 1 spot in the other direction. What should I label that? Well, D prime. Same thing with C. So that's C prime. And same thing with B. 1, 2, 3, 4, 5, 6. So we had to go 3 spots to get to our line of symmetry. We have to go 3 spots further. That is B prime. Now, once you draw your lines, and your lines are going to be way neater than mine, you should notice that the blue image, or excuse me, yeah, I should actually just call it the image, is exactly the same as our red pre-image, okay, except for they're mirror images of each other. Yes, they're the exact same size. Yes, my angle measures are exactly the same. So my C and my C prime have the same angle measure. Okay, same with my B's and my A's and my D's. They're exactly the same. They're just flipped over this line of symmetry. Okay? So we have found the coordinates, or excuse me, we have found the image of A, B, C, D. So forgive me, but I actually did B for you. A now can be done in a different way. You can either count like we have here, and it's very simple. All you would have to do is say, well, A prime, because it says find the coordinates of the image, A prime is obviously negative 4, negative 3. And B prime, where is it sitting? It's sitting at 1, negative 3. And C prime, where is it sitting? 0, negative 1. And D prime, where is it sitting? At negative 5 and negative 1. Now, I want you to take a look at what you're seeing, right? Oh, that was pretty bad. Negative 5, negative 1. I want you to take a look at this for a second. If you look at your new points, you should realize that they have a similarity to our, and let me switch back to red, they're very similar to our original, our pre-image, A, B, C, and D. Because A is negative 4, positive 3. B is 1, 3. C is 0, 1. And D is negative 5, positive 1. Now I want you to take a second and ask yourself, whoa, sorry about that. That one should be, that's going to be a little too big. That one should be negative 5, positive 1. I want you to ask yourself, are there any similarities between my pre-image points and my image points? And hopefully you're realizing that they're exactly the same except for, and let me get another color, a third color here, except for my y values. And what's the only difference? Each of my y values, each of my y values, that should be positive 1, each of my y values got multiplied by negative 1. This only happens when we're reflecting over the x-axis. If you're asked to reflect a figure over the x-axis, you can do it in one of two ways. You can either count the number of spaces from the original point to the line of symmetry, and then count the same number of points in the opposite direction and plot your new point. Or you can move a little bit quicker and you can look at your original points, A, B, C, and D. Take your coordinates for A, negative 4, 3. And since we're flipping over the x-axis, all you have to do is multiply your y value by negative 1. So 3 times negative 1 is negative 3. And you already have your new coordinate. A prime is going to be negative 4, negative 3. B prime will be 1, negative 3. Because all we did was multiply this guy by negative 1. And you multiply this guy by negative 1 and you get 0, negative 1. Now, we're not going to do it now, but if you were asked to flip a figure over the y-axis, so that would mean making your y-axis your line of symmetry, you could also do this in one of two ways. You could either count from where your original point was to your line of symmetry and count the same amount in the other direction and plot your point. Or, since we're moving across the y-axis, you can multiply your x value by negative 1. So for instance, if you had a point here, negative 3, positive 5, and I asked you to reflect it over the y-axis, you don't need to go 1, 2, 3, 1, 2, 3, and plot your point. You can just look at this and say, alright, I'm going over the y-axis. I need to multiply x by negative 1, so my new point better be at 3, 5. Okay, so we went over some basics today on reflections. Even though my notes right here say translations, we're really talking today about reflections, so forgive me. This is reflections video notes. You might want to change that yourself. Still a lot of the same characteristics. When you perform a translation or a reflection, you still have to work with your image and your pre-image. Sorry, your pre-image and your image. So just change that one word to reflections and turn this one word from I can translate a figure to I can reflect a figure. Okay? Same exact things hold true. Alright, I'll see you tomorrow, where you can spend a little bit of time practicing.